Hey, welcome back. I purchased a drill bit sharpener. You might have seen these machines in different colors, slightly different shapes from the housing, but the base principle is always the same. You have a single super abrasive grinding wheel in here. I will take the cover off later. And you have multiple stations to perform your grinding. The drills are held in this collet chuck with two alignment flats. There is an alignment station, so you can align the drill correctly in the collet. And then you just go through your motions, grinding the general drill shape, split pointed, and thin the web. So you have 3 steps on these grinders, and they're incredibly fast to work with. At my day job, we used to have from the same manufacturer, Motom. They are supposed to be the inventor of this style of machine, and they still are around. I think they started making and selling these in 1990. As far as I can tell, these are made in Taiwan. Fairly well made. You have your set of collets in here from 2 to 13 millimeters in 1 millimeter increments. But there is also a second set of collets in 0.5 millimeter increments. And when you look at these collets, they kind of look weird when they step up from small to big. That's because they are inversed ER20 collets. They are clamping here on the back, not like a regular collet here in the front. This is just a relief cut. The actual clamping is happening back here. And that's just due to the design of this holder. This one has a CBN grinding wheel. You can get also a diamond wheel if you do carbide drills. This is absolutely a one-trick pony. It does drill bits, period. It doesn't do countersink, it doesn't do end mills, it doesn't do reamers or counter bores, only drill bits. And also NC spotting drills can be ground on these very effectively. There's tip angles from 85 to 140 degrees, and that's it. Doesn't do flat bottom drills. It's really a drill sharpener. It's not a tool and cutter grinder. It's kind of limited in its capabilities, but what it does really well. At my day job, as I said, we have the same one for years at my day job, and I used it a metric ton. It's very nice to go through your drill index and just sharpen every single drill in a short period of time to as good as new. It's supposed to grind up from 2 millimeters, but in reality, at 2 to 3 millimeters, the settings get very, let's say, optimistic. Realistically, you grind from 3 to 13 millimeters with this machine. Below 3 millimeter, you get in the territory of specialized drill grinders with an alignment optic like the Meteor or the Blue Point machines. This one is more of a very utilitarian drill sharpener for general use. The colleagues at work even take it along at machine installs if they have to resharpen drills for cordless drills. Beats having to push a dull drill with a cordless drill through some kind of a machine frame. So yeah, why didn't you get a stationary machine that goes on a separate stand? Well, that's a problem. I don't have room for a separate machine that goes on a stand. This one, despite being fairly heavy, can go in a drawer of a cabinet and is out of the way, and I just take it out if I need it, and it does what it needs to. And if I need something specialized, I have a surface grinder, I have a tool and cutter grinder, and I have a D-bit grinder if I ever put it back together. So many options here. Let's say I have a 6.5 millimeter drill and I want to sharpen it. Currently there is a 6 millimeter collet in here, and that's too small. ER collets do not want to clamp bigger than their nominal diameter. That ruins the collets. So 6.5, I can use 6.5 millimeter collet because it will clamp smaller and nominal. Make sure it's clean. This is the 2-part collet chuck. As usual, you hook the collet into the nut like on a mill chuck, your collet chuck for a milling machine. Then you put it together, just like this, and you insert your drill, and you very lightly tighten the collet so you can still spin and axially align the drill. Over here we have the setting station, or the alignment gauge, or whatever you want to call it, and it has a graduated dial, which is, well, kind of, it's a little bit of a guessometer. You align the lines on here with this hash mark on the sheet metal housing between 6 and 7, means 6.5. This is important, but really a kind of precise setting is good enough for this style of grinder. Then you put the alignment gauge in. There is a lip in here that you use to align the cutting edge of the drill with, and a end stop that you push the drill up against. So you basically push it in, spin it against the hard stop, and then you tighten the collet chuck with the snurled ring here. That's all the setting that's needed. Now we can already go for grinding. So for the first step we grind the tip angle, and this is this station here, which does like a 45-degree motion back and forth. And you insert it in, and then you go back and forth until the grinding wheel sparked out on the drill bit. You will hear that. Okay, the drill angle. Now we go for this back station, which does the split point, and there is no motion to it. You just drop it in and do that 2 times 180 degrees opposed. Okay, that's the split point, and now we go for web thinning. This has a motion. And that's it. That's one very nicely reconditioned drill bit. So this is the finished drill after grinding. This is the split point surface, and the web thinning removes only a tiny bit of material right here at the chisel point to reduce the force needed for drilling even more. The grinding wheel in this grinder is rather coarse, and it needs to be for material removal. Right here at the chisel point you see a little bit of a burr, and I just use a piece of copper and drag it along the burr, and this shears the burr off cleanly and leaves a nice cutting edge. But in reality it's not really necessary, because once you put the drill to the material, the burr gets removed anyways. How much does it take off from the length of the drill bit? Well, that's fixed, built into the setting station or in the setting gauge. It's about 0.5 millimeters. If you set the drill in here, grind it and go back, there is about 0.5 millimeters a little lost of the length of the drill. If the drill doesn't clean up in the first pass, you can come back and reset it and do it over. It's like a less than a minute for a drill bit, I guess. A little bit more if you have to change the collet and make sure everything is clean before you put stuff together. Okay, let's see what's inside the grinder. We have a CBN grinding wheel with a contour. It's beveled. The bevel is what's doing most of the grinding on the drill bit. It grinds both the taper, the tip, and also the splitting of the point. And the edge, the sharp edge on the back side, does the web thinning. You have the rotational guide with the 45-degree limit in front here, which can be adjusted for the taper angle. Back here is the station for doing the split point, and here's the web thinning again. The web thinning can be adjusted height-wise. Well, you kind of tilt it into the grinding wheel, but that's an adjustment I found that usually not necessary to mess with on these Motom machines. They are set from factory to a decent value. The machine also comes with a bunch of shims. If you don't want to mess with this adjuster and want to change the setting only for one particular drill, you can put the shim on here and do a lighter relief web thinning. I never found a need to use these, but they are there if you need them. And that's it. And then there is a funny sheet metal fan bolted onto the grinding wheel. The idea, I think, here with the wheel is to move grinding dust to the outside. These are, by the way, fairly messy machines, despite the little amount of grinding they do. But you end all over with fine steel dust. At least you don't get grinding wheel dust because electroplated wheel. There is a dust extraction port as an accessory that comes in from the underside and sucks the grinding dust out through this hole. I forgot to order it, so I'm going to 3D print my own because I'm a cheapskate. I 3D printed a dust port, and since I didn't want to take major modifications to the sheet metal of the grinder, I'm using the holes that hold this sheet metal cover to the hinge to allow it to flip back. The sheet metal cover has some vent slots in the back, and the adapter just covers those up, and I'm using the shop vac to pull air through those slits. It's not an ideal case, especially since the grinder itself has a lot of open holes to the outside, but the shop vac I'm using is rather powerful, and as far as I can tell so far, the dust extraction this way works. Time will tell if this is a good solution. Otherwise, I can still cut a hole in the sheet metal. The original dust extraction came in from the underside, but I didn't like that. You want to see some drilling, I guess. I sharpened up a 6mm drill bit, and I have some cold drawn mild steel ST37 up here in the milling machine. And I'm going to drill two holes, one directly into solid stock and one with a pre-drill, just to show the difference in the result of the drilled hole. I'm going to drill with power feed, so we get consistent results here. So both holes get spot drilled, of course. And I'm going to pre-drill the second hole with a 2mm drill. Usually I would use a 3mm drill for pre-drilling, but I have this right here now, so I'm going to use this. And now for the freshly sharpened 6mm drill. We lock the quill. And I'm going to run it at 1000 RPM and a feed of 63mm per minute, which results in a chip load of, or a feed of 63 micron per revolution. And over here we drill the second hole directly into solid stock, also with the same feed rate. So the obvious observation is it drills. The less obvious observation is the hole with the pre-drilled hole is nicer. And this can also be said for the tolerance of the hole. Let's get some gauge pins and check the diameter of these holes. So let's start big. 6.05 millimeters. Wants to start but doesn't fit. Doesn't want to start at all. 6.04 wants to start, but the hole tapers a little bit to the bottom. And on this one, nope, that's a no-go. 6.03. Okay. The drilled into solid stock hole is 30 micron over nominal, 35 micron over nominal. The pre-drilled hole, 6.03, doesn't fit, wants to start. 6.02, well, here it fits obviously, and here, yeah, it wants to start. I could force it in, but never get it out again. 6.01. Whoop. Oh. Yeah, that's a fairly tight fit. I would call it, well, this is a 6.00 millimeter pin. And this is kind of a loose fit. And the 6.01 millimeter pin is a very snug fit, so it's between those two pins. What I wanted to show here is that not only the drill grinder grind drills, but also gives you some added value with a little bit of information about drilling rather precise with an ordinary twist drill. Having a small pre-drilled hole greatly reduces the force needed, the axial force needed for drilling, and therefore the hole just gets way nicer. Because even with a split point and thin web drill, you still have the center of the drill, which runs at a surface speed of 0 and very close to 0 if you move out a little bit. And that does just not cut very well. It pushes material around. And that leads to oversized drilling if you go into solid stock. That said, not every hole needs to be a precision bore. Drilling into solid stock can be perfectly fine. If you just run a bolt through this hole and need some clearance, yeah, don't bother with pre-drilling if the drill is not like this diameter. If you need to pre-drill for a reamer, yes, the quality of the pre-drilled hole makes a difference. Not only roundness and diameter, but also the surface finish of a pre-drilled hole affect the performance of the reamer. Makes reamers way more predictable if you take some care on the pre-drilled hole diameter and hole quality. Let's zoom in a little bit. So a little bit closer up of the finish on these holes. As you can see, the hole with the pilot drill looks way nicer than this one without the pilot drill. And that's because the fact that the drill has zero cutting speed in the center makes the drill wander around in the bore and force the side of the drill into the wall of the bore and not leave as nice of a finish as if the drill strictly went down without any side forces. So consider pilot drilling. And yeah, that's basically it. Everything sits on a fairly thick base plate. Motor is in here. It doesn't sound like a universal motor in a handheld drill. It sounds more like a single phase motor with a capacitor. Well, that's the inside of the machine. Comes with a button. Of course, you should never operate it with the guard open, which I did to do filming. And on the other side, oh, it is a heavy bugger for its size. And over here we have the alignment station. As you can see, when I change the drill diameter with this wheel up here, this lower edge moves up and down. And this is to accommodate the relief angle on different sized drills. There are modifications mentioned in the manual for certain types of drill. For example, special deep hole drills will need you to set double the diameter on this dial. Things like that, but that's not something that happens commonly every day. You better look that up if the grind result doesn't match your expectation. So why did I buy this machine? Well, I wanted a solution to grind general sized drills above 3 millimeters to factory quality very quickly. I can do a very good 4-facet grind on the Dackel S1 tool and cutter grinder or on the D-bit grinder, but it takes quite a bit of time, and this is just extremely fast. It takes like a minute usually, and the results are really good. It's an absolute one-trick pony. And it's not a high precision machine by far. It's, for what it does, it's absolutely adequately precise. But everything, the adjustment in here just has a little bit of wiggle and give. But drill bit geometry for a general use drill gives you quite a bit of leadway to still work very well. Are there better drill bit grinders out there? Yes, absolutely. Meteor, Blue Point. I guess the Darex grinders are better too. Well, they at least look very impressive. But is this a good solution for a shop that just needs to grind twist drills? I would say so. It is. It's not cheap. It's not a cheap machine. I have the invoice here. It's a BSM 13 Duo. Duo is the fact that it can do the split point. There is also a BSM 30 without the Duo that does only the drill angle, the tip, and the web thinning, and not the split point. The price difference between the split point version and the normal version is like 50 euros, so I went with this. It's a 990 euro machine plus tax. The collet, the half-size collet set is 144 euros, and the sheet metal box for the half-sized collet is another 50 bucks. So you end up with 1183 euro plus tax. Comes out to this. And well, since I don't do sponsored segments on this channel, well, I don't do any product placement in general, I bought this machine. I didn't get it from them. Motom doesn't give me any money, so I show it. But this is also not I got this machine 5 minutes ago and want to do a preview and a long-term experience, because I have long-term experience with the same style of grinder from my day job in the non-split point version. So that's the Motom BSM 13 Duo. I hope you enjoyed. Thank you all for watching, and I'll be back.